Hello, and welcome to this lesson in quantitative reasoning. This is part one of two videos about statements in logical connectives. These go along with your text. And there we go. All right, so we're going to learn about statements in logical connectives. The first thing we're going to talk about is what is a statement. The next thing we're going to talk about is how we talk about whether a statement is true or false and how to negate it. And then we're going to talk about taking simple statements and connecting them to be larger statements. That will be in future videos, but parts 1 and 2 are just about statements, negating them in simple statements. So, and we also are going to identify some logical connectives. So in part 1 here, we're going to identify and negate simple statements, identify and negate quantified statements, which means statements that start with some or all. So, definition of a statement. A statement is a declarative sentence. So this book says statements can't be opinions. Okay, that walks a fine line. If I say apples are red, you could say, well, Granny Smith apples aren't red. So, it'll be clear within the context of what we do in class, whether something is a statement or not, or whether it's intended as a statement. But it's a sentence or mathematical expression. 3 plus 5 equals 2 is a true statement. No, it's a false statement. There you go. Were you listening and paying attention? 3 plus 5 equals 8 would be a true statement, but both are statements because they can be either true or false. Study of logic is based on combining and reordering and connecting statements to draw conclusions about the truth values of larger statements. So, a statement has to be a sentence or mathematical expression, so it has to be a full sentence, and that has to be able to have a value of true or false. This is where the opinion gets kind of funny, because if I make a statement that's my opinion, I think it's true. But anyway, it has to be true or false, but it can't be both at the same time. So, the sentence, Pluto is a planet, is now a false statement. When I was in school, it was a true statement, but it's still a statement. So, I would not expect you to understand something about astronomy in this class to tell me whether something was true or false. I would tell you whether to assume it was true or false in the context of what we were doing. But if we want to, so this is a false statement. If we want to make it a true statement, we would put not a planet, and that would be called the negation. Pluto is a planet, Pluto is not a planet, cannot both be true at the same time. So they're both statements, and one is the negation of the other. So, which of the following things are statements? So email provides a means of communication. That's a full sentence, it's a statement, and it's also true. 12 plus 6 equals 18 is a full math sentence. It's a statement. It also happens to be true. But even if it had said 17, it would be a statement. It would just be a false. Look over there as a command. Commands and questions. Anytime you have a question, you also would not say it's a statement. So if you see a question mark, no. Are you coming to the park? Not a statement. It's a question. Now, the book and I differ a little bit on this. I can say orange is the best color. And from my opinion, that's true. The book says it's an opinion, which is not a statement. I will try not to get you too tangled up in that, but be aware of the book's stance on this when you do the homework. Okay. Now, statement or not a statement we just talked about. How about negation? Negation means opposite. So you want to write the statement so that has a statement that has exactly the opposite meaning of the statement you see. So you see 3 times 5 equals 25. That is a statement. The statement presently is false because 3 times 5 is 15. So the negation of that would have to be true. So if I say 3 times 5 is not equal to 25 in math, or we say not 3 times 5, I would say 3 times 5 is not 25. The statement is false. The negation is true. There's no way they could have the same value. They're both statements, so that's a proper negation. Now we have another statement. The Eiffel Tower is not in London. So in English, this one is fairly simple to write the negation of. So the negation of that statement would be the Eiffel Tower is in London. In simple statements that don't involve the word some, all, none, there is one. If you don't have any of those quantifiers going on, usually the word putting in or taking out the word not is how you will negate the statement. I will eat lunch today. The opposite of that. That's true. I always eat lunch. I will not eat lunch today would be the opposite of that. You just put a not in. So that would be how you negate the statement. So some vocabulary here is knowing what the word negation means. So this goes through that one. I just said that already. So there are some types of statements that are more, you have to be more careful when you quantify them. When we use the words all, some, none, there is one, these are called quantifiers. It's not just saying something about one thing. It's saying something about a group, it's about some part of a group or no part of a group. And these quantified statements, you have to be careful when you negate them. So some cats have fleas. That's true. It is also true that some cats do not have fleas. So that cannot, if some cats have fleas, it's possible that some do not at the same time. So that is not the negation of some cats have fleas. So some cats have fleas means literally there's at least one cat somewhere in the world that has fleas. So it's like saying there exists a cat with fleas. At least one cat has fleas. It's the same as some cats have fleas. The opposite would be not one cat or no cats have fleas. So, because in order for this to be false, it would have to be you can't find one cat with fleas, because if you find one, it means you've met the qualification of some. Every girl in Memphis is named Mary. That's probably false, because there are other people living in Memphis, other girls in Memphis. So, some girls in Memphis are not named Mary. So every girl in Memphis is not named Mary wouldn't be the negation, because there might be one. You just want to say, but not all of them. So you say, no, wait a minute, not every girl. There exists a girl that is not named Mary. You have to be careful. Every girl, all becomes, there are some not. Not, there are none. We feel like all should be the opposite, should be none, but that's not true, because if all girls in Memphis are named Mary would be false, but no girls in Memphis are named Mary would also be false. They have to have opposite meaning. So we will manage this one. The next slide goes into it. And no sharks are mammals. Would not be all sharks are mammals. The opposite of that could be there is a shark that is a mammal. So you have to be careful with the words none, some, all. And we're going to move down to the next slide. So when you see all A are B, that's the same. These are equivalent statements. This is the same. This is not the opposite. That's the same as saying there is no A that is not B. The way you negate that is saying there is an A that is not B. Okay? Some A or B means there is at least one. These are equivalent, not negations. Okay? So when you have no A or B, the equivalent is all A or not B. This could get confusing if you think of these as negations. They're not. Some A or not B, not all A or B. So the opposite of saying some are not, you take out the not and you change the word some to all. So there's a process here. When you say all are, when you negate that, you say some are not. We'll see that in a slide in a moment. So which of the following statements are equivalent to the statement all whales are mammals? Some whales are mammals is not the same. Some whales are not mammals is not the same. The equivalent. They're looking for something that's the same, not the opposite here. No whales are not mammals. That would work. No whales are mammals. So this is the double negative. No whales are not means all are. You can't find one that isn't means they all must be. Okay? Some whales are not mammals would be the opposite. This would be the negation. So if all whales are mammals, it's true. Some whales are not mammals would have to be false. If some whales are not mammals is true, then all whales are mammals would have to be false. So this one would be the equivalent. No whales are not mammals. So if your language skills are challenging, you're really going to have to think this through. But I'll try to show you some mathematical process. Look, we have all are. If you want to write the negation, you write some are not. So negations do involve either inserting or removing a not. But when you have these quantifiers, alls become sums and sums become alls. So that's going to be the key to negating quantified statements. All right, so I'm not going to go through all these. You can read those and see. You can stop the video and see why I chose the ones I did and told you which was the equivalent, which was the negation. So negating a quantified statement can be trickier. Now we're talking about negating, not equivalence. The negating a simple statement. So this statement we had before, all girls in Memphis are named Mary. It's very likely false. This girl's named, I'm sure somebody who knows somebody in Memphis knows a girl who's not named Mary. So you have to think about the meaning of the word. So if I want to write its negation to be true, it's tempting to say no girls in Memphis are named Mary, but that's not true either. If I have a false statement, its negation has to be true. So the correct statement could be not all girls in Memphis are named Mary, or some girls in Memphis are not named Mary. So some girls in Memphis are named Mary would be written the opposite, would be no girls in Memphis are named Mary. So here you have the some are, and the opposite would be no girls are. This is where we get a little, I would say some are. No girls in Memphis are not named Mary would be, so you could say none of the girls in Memphis are named Mary. This is where it gets tricky. You don't see the word not in that negation. But the some goes to an all. If you're saying a part is, you can't say a part is not, because those things could be true at the same time. If you say a part is, you have to say the whole all or not. If you say all are, you don't have to say all or not, because those could both be false at the same time. If you say all students in Math 140 are doing their homework. If I said the opposite is all are not doing their homework. Now, all students are not doing their homework, so that's a false statement. So you say, well, then all are not doing their homework. No, in English, you might interpret that to be a true statement that leaves the possibility that some are, but it doesn't. You have to say, some students in Math 140 are not doing their homework would be the opposite of all students in Math 140 are doing their homework. So all goes to some are not, some are goes to all are not, or none are. You'll get used to this when you do the homework. There'll be practice in the homework. So, and here's this in a picture. All A are B, some A are C. So you start with the all, and you go to some are not. If you start with some are not, you go to all. If you start with some A or B, you go to all are not. And sometimes people write this as none are. That's another way that the math is much clearer. We're going to see with the symbols, once we turn statements into symbols, the meaning is very clear. Our verbal language is ambiguous. So that's the reason we have all these symbols in math, to make our meaning very clear. So, what is the negation of the statement, no girls in Memphis are not named Mary? No girls in Memphis are not named Mary is the same as saying all girls are named Mary. So the negation from that slide before, so we have the case of all are. Some girls in Memphis are not named Mary would be the way we would negate that. Okay, so that's the end of part 1 of this lesson. The trickiest part of this lesson is the negation of the quantified statements. We're going to look some more at statements and how we connect them in the next part. Thank you for joining.